Hello, grade 9s. Today we are going to talk about 8.5, which is all about surface area of prisms, except this time the prisms have composite bases. So this lesson is really going to be a blend of 8.3, our composite shapes, and 8.4, our surface area of prisms. Now, just a couple of reminders about prisms. A prism is a shape that has two identical and parallel bases. So a cylinder has these two identical circles that are parallel to each other. A rectangular prism has two identical bases that are rectangular and parallel to each other, and so forth and so on. Now we're going to take a look at these complex prisms. Prisms that have like weird shaped bases. Bases that we don't really have names for, right? Because they're not a basic shape. They're a combination of shapes or like an irregular looking shape. So below here, I have three complex prisms. And just like we did before, we are going to shade in the base and we're going to label the height of the prism, keeping in mind that the base will always be identical and parallel to the second base in this prism. And all of the other remaining sides, if I were to unfold this, would make one large rectangle, right? Because if we could also remember, not only are our bases identical and parallel, but all of our lateral faces, all of our side faces of our prism, if we were to unravel them or unwrap them, we would end up with one large rectangle. So here in my first shape, that kind of looks like a treasure chest, I have this shape. It kind of looks like a half circle and a rectangle put together. This would be considered my base. And I would have that exact identical shape. I'm just going to draw the outline of it. On the opposite side, and it would be identical and it would be parallel. If I unwrapped the rest of the faces, the ones I haven't shaded in, the lateral faces, and I unwrapped it, I would form one big rectangle. Keep in mind, base does not mean bottom. So as we never assumed that the base was the bottom before, the base is not bottom now. Now the height of my prism is always defined as the distance between the two bases. So here I have my height of my prism. It'll be the distance from that front half circle rectangle shape to the back half circle rectangle shape. Now there are two more prisms here. Can you pause the video, take a moment, shade the bases, label the height. Go. Welcome back. Okay, so when I take a look at this one's a regular shaped, for sure. And it looks like a lightning bolt. This lightning bolt would be considered the base because there is an identical and parallel lightning bolt at the bottom of my shape, the way that it's oriented right now. And so these would be the bases, and then the height would be the distance connecting my top lightning bolt to that kind of bottom lightning bolt. And in this last shape, we have this house-looking thing. In this house-looking thing, my prism's base would be the house-looking thing. It would be the combo of the triangle, rectangle that I've got here. So this would be my base, and this would be my base. Just as a reminder, when we take a look at our prisms, right, all the lateral faces, the lateral area makes one big rectangle. So if I have a side that is definitely not rectangular, like whether it's a flat rectangle or a curved rectangle, that's my big indicator that is likely the base. And then again, the height of my prism is defined as the distance between the two bases, not always up and down. Now, the wonderful thing about these prisms is that to find a surface area, we use the exact same formula. That SA is equal to 2B, which stands for area of the base, plus P, which stands for perimeter of the base, times the height of prism. Now, the big difference here is this area of the base is going to be an area of a composite shape. That's where that 8.3 in our notes comes in. So for this first treasure chest looking guy, the area of the base is going to be that area of the rectangle plus an area of a half circle. For my house looking guy over here, this last third shape, my area of the base is going to be the area of that rectangle plus the area of the triangle on top. So it's going to be a little bit extra work in the sense that my capital B and my capital P will not be basic shapes anymore. They will be composite shapes. But otherwise, my overall setup is the same. So today in class, we are going to take a look at two different examples. The first one here is this prism. Can you take a moment and identify in your heads what the base is and what the height of my prism is? And if you're confident, shade it in. Lovely. Okay, when I take a look at this, as a reminder, I told you that if there's any side that does not form a rectangle, that is your big hint that that is going to be your base. So here I have this L shape, and this L shape is definitely not a rectangle, but I notice I have two identical L shapes that are parallel to each other, which is exactly what we need in a base of a prism. And the height of the prism is going to be the distance between those two bases. Now, just like we did before, we are welcome to go ahead and redraw that base, just so that we can make sure that we're not getting any of the side lengths kind of mixed up. Also because sometimes its dimensions are labeled at the back. Sometimes its dimensions could be labeled at the front. And sometimes they're labeled in some of the front and some of the back, wherever the bases are. So sometimes it's nice to draw that out so that we can identify all those dimensions quite easily. So I'm going to redraw the base, and I'm going to go ahead and relabel it. So I have 6 centimeters, I have 6 centimeters, I have 12 centimeters, and I have 7 centimeters. And I have two sides that are not labeled. I am eventually going to need those sides, so let's talk about them now. This side length here, can you take a moment and try and figure out its dimension, and then the bottom one as well? Okay, pause the video, take a couple seconds, come back and confirm with me. Okay, you've done it. Now when I take a look at this L shape, I have that blue kind of vertical line segment. I'm going to look at all the other blue vertical line segments, and those two small blue ones in the middle and on the right add together to give me the big blue one that's on the left. So I have 6 plus 7, which ends up being 13 centimeters. Same kind of vibe for my pink bottom. I have a horizontal line segment, so I'm taking a look at the two other horizontal line segments. Together, the two small ones make the large one, so I get 6 plus 12, which gives me 18 centimeters. Now these numbers will be handy when we're doing our calculations for our base, both our perimeter and area of the base, which is why I'm tackling that now. Okay. So we are going to go ahead and calculate the surface area. And reminder, for the surface area, we need to find the area of the base, so the area of that L shape. We need to find the perimeter of the base, so the perimeter of that L shape. And the height of the prism, which we've already identified to be 20 centimeters. Then we're going to take our numbers, plug them into our surface area formula, and call it a day. Now, when we start with our area of our prism, or area of our base, I should say, we can see that this L shape is made up of two rectangles. Now, it doesn't matter how you see them. If you see one rectangle like this and one at the bottom, if you see it this way, one over here and two over there, or even if you see it as one big one with a smaller one removed. However you choose to view it, you should get the same final answer, because in L-shaped kind of composite shape that I have here, it is made up of two rectangles. As long as I'm using the appropriate dimensions, I should be good. What I'm going to do is I'm going to separate it this way. And because I have two rectangles, I'm going to label those rectangles 1 and 2 so that I can say like area of rectangle 1 and area of rectangle 2. No problem. And when I do that, I'm going to make up a formula for my area of my base because it happens to be a composite shape. So I'm going to say area of shape 1. And I can call it shape 1 because I've labeled it shape 1. Usually if I label things with numbers, I put a circle around it so I don't confuse it as like a number that I'm calculating with. And I'm going to add it to area of shape 2. And if you're like, Miss T, why did you put a big space in between? Mostly just so that I can make sure things are lined up as I work down. And that's really all. Now, both of these shapes are rectangles, and the formula for rectangles is length times width. And because I'm going to use length and width twice, one for shape 1 and one for shape 2, those lengths and widths are different. So I am going to personally say length 1 and width 1, length 2 and width 2. And I could put little circles around it again because I don't want to accidentally use the same numbers for both, and I don't want to get them mixed up. Next here, I am going to plug in the numbers. So for my first rectangle, I have 6 and 13 as the dimensions. And for the second rectangle, I have 12 and 7 as the dimensions. Okay, and now we could go ahead and plug those in. 6 times 13 will give me 78. And 12 times 7 will give me 84. And when I add those together, 78 plus 84, I should get 162. Now, for my final answer for area of the base, I do need to have units involved because this was all, my dimensions are in centimeters. My units for area are going to be centimeters squared. And I do want to talk about a couple of things. So before, when we were dealing with composite shapes, we would have probably done something in 3 steps. We would have found the area of rectangle 1. We would have found the area of rectangle 2. And then we would have added them together, right? And in each of those steps, we would have shown like 3 lines of work here, which is really fantastic. We are essentially showing the same amount of work. We are welcome to do that separately to figure out my area of my base. I can do that in 3 steps still. But I did want to show it as one large step, but one large, very organized step. Because it's not okay to do it as one big step and then have no idea where those numbers are coming from. I have no idea what shape you're referring to. Like, that's not cool. But here, we have it really, really organized. I can tell that all of this deals with this first rectangle. And I can tell that all of this deals with this second rectangle. And then I have my combined area at the end. So as long as it's excessively clear, just like we have displayed on the screen right now, you're welcome to do that as one big mega step because you're still showing all of the same information. Okay. Next, I'm going to find the perimeter of my base. My perimeter of my base. Now, oftentimes for my perimeter of my base, I know I have to show 3 steps: formula, plug in, final answer. For these complex shapes, usually if they're straight line shaped, there's not like a really good formula to say or to write. So instead, we'll just say the sum of sides, which just means add up all of the sides together. And when I take a look at this, I'm not adding sides in the middle. I'm just like, or lines that go through the shape. I'm just adding in the outskirts. Make sure you don't repeat ones over and over again. So I'm going to circle what I'm starting with. So I'm going to go 6, and then I'm going to go clockwise around. Plus 6, plus 12, plus 7, plus 18, plus 13. Right? I'm just going around and adding all of my side lengths together. And when I add all of those together, I should get 62 centimeters. And again, I showed all 3 steps for perimeter. Life is pretty good. My height of my prism, we've already talked about it. Like I said before, and I'll say it again, I like to state it individually because I know people tend to mix up height of prism with heights of triangles and heights of parallelograms. So I like to have that explicitly stated elsewhere. And then I have my surface area formula. My surface area of any prism is calculated by 2b plus ph, and I am simply plugging in those numbers. So for B, I got 162. For P, I got 62. And for H, I got 20. And I'm welcome to plug this in as 1 step in my calculator, as 2 steps, as many steps as I need. And here I've got 2 times 162. What did you get? 324. And 62 times 20, what did you get? 1240. Just so you know, I imagine that even though I'm not there, hopefully you're yelling all these numbers at a screen. Make me feel really nice. Okay, and I'm going to add these last 2 numbers together, and I get 1,564 centimeters squared. And I do need to make sure I have those units. Now, again, if you are taking a look at things and you're like, oh my gosh, I'm doing things in pencil, mine doesn't look as organized because I don't have that color coding that you get if you're working on a device. Feel free to kind of like box your steps so that they're separated from each other, and you can go ahead and label the boxes. So this was step 1, this was step 2, this was my step 3, this was my step 4. As long as your work looks clearly organized and easy to follow, and all of your steps have the minimum number of work shown. So my formula, my plugin, and my final answer. If I am doing things like my composite area of my base here, I'm going to have 2 formula steps. One of like the generic vibe of I'm adding shapes together. One of like the placed in specific shape formulas. But I still get the same kind of final answer there. Okay. Hopefully you're looking at this and you're like, oh my gosh, this isn't as bad as I thought. We know how to find the area and perimeter of composite shapes. We know how to find the surface area of prisms. So hopefully you're like, okay, it's more work, but I could understand how they're being put together. Now we have one more example to do, and it's this guy. If you could, can you please shade in your base? Identify what your height is going to be of your prism. And I'm actually going to redraw my base once again, just so that we're all on the same page here. Okay, take a moment, pause the video, do those things. Go. Oh my gosh, welcome back. Okay, so my base in this shape is that triangle rectangle combo because I have an identical and parallel triangle rectangle combo, or you could be like that house shape on the other side. All of my other sides are in fact rectangles, which makes it nice. And there we go. Now I'm going to redraw that triangle rectangle combo. Your redrawing doesn't have to be perfect. It just kind of helps you identify those labels here. Okay. I know my height of prism is the 6 inches here. It's in that same kind of orientation or dimension as the height of prisms. You could have labeled it there to begin with, but I'm just going to go ahead and label my sides. Now, in my rectangle here, I of course know that if the bottom side of my rectangle is 4 inches, the top side is 4 inches. And same kind of idea, if my right side of my rectangle is 6 inches, my left will be 6 inches. I also know that this side length here is 4 inches. And we're kind of assuming that these are identical. So that's there. Realistically, I have a lot of my dimensions. Like if I'm thinking ahead, I've got the dimensions to find the area of a rectangle, no problem, right? Length and width. And if I'm thinking ahead, I need base and height of a triangle to find the area of a triangle. But one of the things that I might notice, oh, hold on. I made a boo-boo. Go back, reverse. I accidentally labeled the side as 4 when I really should have labeled the height as 4. So let me go back here because I've just noticed now that there was an arrow and I accidentally shaded over it. I realize now it was pointing to the height as 4 inches. Hopefully you all caught it and were yelling at the screen. You're like, no, Miss T, don't let us down. Okay, so for my triangle, I do have these dimensions. I have the base and I have the height. And remember, base and height are always going to be perpendicular to each other. So let's start by finding the area of the base. So my area of my base is going to be the area of that rectangle. I'm going to add it together with the area of that triangle. The formula for the area of a rectangle is length times width. And the formula for the area of the triangle is base times height divided by 2. Now, I could have labeled this as shape 1 and shape 2 because my shapes are different. I decided to call it rectangle and triangle. I also don't have any overlapping of letters here. So like length and width are specific to a rectangle and I don't use length and width in triangle and vice versa. If I was using base and height for rectangle here, my base and my height aren't necessarily always going to be the same. So it would be a good idea to continue labeling them further. But as I've mentioned at the beginning of this unit, I really use length and width for rectangle way more often than base and height because I worry about getting confused if other shapes are involved. And length and width are a safe bet that you won't often mix them up with anything else. Okay, plugging in numbers. For my rectangle length and width, I've got 6 and 4. For my triangle, I actually also have 6 and 4. So this is a situation where they would have been the same, but it's not always guaranteed that way. Now 6 times 4, well, that's just 24. And 6 times 4 is still 24, except this one's divided by 2. And again, we can do all of the math here as mental math because none of this particular set of numbers is going to be overly complex or require a use of the calculator. So all of these, we should feel relatively comfortable with the numbers provided. Again, you have the calculator for this unit, but for a final exam, if I gave you a question like this is actually one where you wouldn't need a calculator for. All these numbers are actually quite nice. For my area, I do end up, for my area of the base, end up getting 36 inches squared, and that's very exciting to me. Next, I'm going to take a look at my perimeter. And just like we said before, there's not really a specific formula we're going to use for perimeter of my shapes here because it's an irregular shape. I know I'm going to add all the outsides together. So I can say that it's the sum of sides, because remember, sum means adding. Okay. But I'm noticing a big issue here that I'm missing 2 of the side lengths, right? I have a 5-sided shape, but I only have 3 of them. Okay, these 2 side lengths, based on how this triangle is drawn, are going to be identical to each other, which is very exciting. However, I do not know what either of those side lengths are, which is very frustrating. Now, we actually can't guess, and we can't just assume it's 4, but I do notice that there is a right triangle here, right? And I know 2 of the 3 sides of a right triangle. And what could we use to find the missing side in a right triangle? And hopefully you all yelled it out at the screen here. We could use Pythagoras. Yay! Okay, so what I take a look, I'm just going to redraw that triangle again to make it super clear to us. And I'm going to redraw in the exact same orientation. So the bottom is 4 inches. This side length here is definitely not 6, because 6 is the whole way across. So this side would actually be only halfway across, which would be 3 inches. And I'm looking for this guy. It would be my hypotenuse, my unknown. When I go ahead, I actually need to do Pythagoras to be able to figure this out. And so I get a squared plus b squared is equal to c squared. And as we remember, the hypotenuse, the one that's opposite the 90-degree angle, has to go in the C position. So since I don't know what that is, I'm just going to leave it as C. I don't know. And then A and B are going to be my 4 squared and my 3 squared accordingly. Now again, all these numbers should be numbers that feel pretty good to you. 4 squared is 16. 3 squared is 9. And I can add those together. 16 plus 9 is 25. And to get C alone, I'm going to have to square root both sides. And I get the square root of 25 is 5. And I can reorder that answer here. So C is equal to 5. And if all my other sides were measured in inches, then C, that side length, is going to be measured in inches. So just to recap here, we're looking for the perimeter. Oh gosh. We were looking for the perimeter and we're like, yes, definitely add these 5 sides together. We did not have 2 of those sides. They looked pretty much identical. We could not just assume they were 4 or 6. We had to use Pythagoras to find them. This will not occur in every single question, but will occur every now and again. Please never assume a side length is a particular number if it is not labeled as such. So I know that this guy is 5 inches and this guy is 5 inches, which makes it really easy now to go ahead and calculate the perimeter. Just going to add up all of those side lengths. And for me, I like to circle the number that I'm going to start at and then go clockwise, because especially in shapes that have lots of sides like that L shape, I tend to add an extra side, like go around the circle more than once or forget something. So here I am. So I've added in those numbers, and I could go ahead and actually do that addition, and I should get 24 inches. Okay, the height of my prism. Well, we've already talked about this at the beginning. The height of my prism is that 6 inches. It's the distance from the first house shape to the back house shape. And then now I am ready to plug everything into my surface area formula. My surface area of a prism is 2 times area of the base plus perimeter times height. And I am simply plugging in those numbers. So for area of the base, I got 36. For perimeter of the base, we got 24. For height, we got 6. And again, we are more than capable of taking a look at these numbers and multiplying them together. You do have a calculator. If we had to do some mental math or some side calculations, we could. But 2 times 36 is 72. 24 times 6 is 144. And when I add them together, I get 216 inches squared. Okay. So just to quickly recap, we had an extra step in this question that we did not have in the previous one. And that extra step was that I did not have labeled side lengths, and I was not able just to simply look at the picture and know what they would be, right? When I take a look at that L shape, there were missing dimensions on my L, but I could say, oh, the big side length is made by adding the 2 smaller side lengths together. I could do that without calculation. In this particular example, I was not able to do that. I had to do that calculation. That will not happen every time. However, it will happen some of the time. Quite honestly, a lot of the times when we have triangles involved. So something to kind of keep an eye out for. Again, we're showing all of the work. This one we had lots of space to work with, so hopefully your work looks pretty organized to begin with. But again, if it's maybe harder to read or you just really want to focus on good organization, please show me the order of the steps that you tackled. And again, double checking that in all of our steps, we have kind of all of the bare minimums provided. We have units at the end of our final answers for each of these steps. Plug in. Okay. But as we go along, for Pythagoras, you're probably not showing less work than this. But this is kind of where our pages should match. If you showed me a little bit more like I showed you, then fantastic. If you showed me a little bit less, please make sure that you're showing more, or at least the same. Okay, that is it, and that is all. There's some practice that follows, so please start working on that practice, and I will see you soon. Have a wonderful rest of your day. Bye.